Today, we're introducing HP Autonomy's Under the Hood of HP Idle webcast series. This series is all about going behind the scenes of HP's Intelligent Data Operating Layer, or IDLE, an advanced technology that harnesses all types of human information to enrich solutions and power applications to deliver incredible insights. Today, we'll place a spotlight on the image server and speech server. Jose Colon, Director of Professional Services, will walk you through what the image server and speech server are, how they work, the core technology that powers them, their advanced capabilities, and how this technology can be applied to real-world use cases. I'd like to now pass the microphone over to Jose to get things started. Please, go ahead.
Thank you, and welcome everyone to the Under the Hood workshop and session focused on the image server and speech server components of IDLE server. My name is Jose Colon, and I'm a Director of Professional Services at HP Autonomy. So in this session, we're going to cover a variety of things. This is meant to be a technical session to focus on the capabilities of the image and speech server components and to give you an idea of how they work and how to leverage them. We'll also talk a little bit about use cases and how the technology can be applied. Hopefully some of that resonates with some of your requirements in your organization. So what we're looking at is a slide that describes the IDLE server infrastructure. As you know, IDLE stands for Intelligent Data Operations Layer. It is the operating system for human information that HP Autonomy holds as its flagship product, and it underlies all of the other products that HP Autonomy produces and offers for solutions. In this slide, we'll see that the infrastructure for IDLE is multi-layered. Everything from multiple sources of information that exist in the enterprise and publicly can be exposed through a variety of solutions that are HP Autonomy products, enterprise products, as well as the cloud-based solutions that we can offer to our clients. The connector layer is one that addresses over 400 different types of repositories and 1,000 different formats of information, all funneling that content into an intelligent data operations layer that can understand the information within that content. Having done so, we expose about over 500 different functions that provide usability to applications to understand the information quickly and easily and in a scalable as well as common way. Today we're going to focus on image and audio information, video as well as still images in addition to the audio. So let's talk a little bit about how the leveraging of that information is important once you've got it into IDLE. These 500 functions that I've spoken about, they can be used for a variety of different types of solutions. We've broken them down into 4 different categories: inquire, investigate, interact, and improve. That means that you can search and analyze the data very readily, as well as to personalize it for automatic delivery. The fundamental tenet of the IDLE infrastructure is automation. We highly automate the capability not only to gather the information, harvest it, but also to understand it. And then once we've understood it, to allow it to be leveraged automatically. And one of those contexts is the automatic delivery of information by alerting, whether that's email, some custom application, or some other means. Improving the information is really got to do with an enrichment capability that we have inherent to the infrastructure that allows for deeper analytics and association of information based on the probability theories that are the underpinning of how IDLE really works. At the end of the day, we establish patterns of uses of language and also of patterns that can be identified like fingerprints or facial feature mapping or color contrasts and backgrounds and so forth in order to expose a number of high-value capabilities within the infrastructure. So let's get a little more technical here. The placement of the image server and speech server components are within the connector framework services. Remember that middle layer that we pointed to in a previous slide? Well, this is a little bit more detail on how things are connected and how they work. So just taking a moment to look at how this operates, you can see on the right-hand side that we implement scalability from a higher-level architectural point of view by instantiating different components and allowing them to communicate with each other through configuration of the connector framework services. That foundation and that structure allows for specific customizations of data extraction, data transformation, and data enhancement, and prepares the information for ingestion into the idle server engine. That capability is hierarchically structured by a series of instructions that are placed into the configuration files and embodied in Lua scripts. Lua is a very powerful scripting language that we've standardized on to provide customization capabilities to the processing of the information. Once that's done, we can invoke the image server and speech server components to perform language extraction from the images or the audio files or the video, as well as being able to identify entities or recognize the images and scene detections that occur in still and video images, respectively. So what are image and speech server? We're kind of throwing around these terms a little bit, and we should more discreetly identify them. Both the image server and the speech server are what's called Autonomy Content Infrastructure components, or ACI servers. The various components that make up the idle server infrastructure are all ACI servers. They're all addressable in a consistent and common way and a predictable way, and they produce XML as well as JSON output responses so that your applications can communicate with them in the most effective ways possible. This is important because you may use these components as part of a more comprehensive and elaborated infrastructure, or you may choose to leverage them by communicating with them directly. If you're not familiar with how to use these components, don't worry, the documentation is actually built into the product, and that's one of the great features of an ACI server is that you can address it directly once you've got it up and running and ask it what the possibilities are for it to do for you. You can also make inquiries about what configuration capabilities there are and what functions are available, what responses you should expect, and we've engineered a built-in help facility as well as a built-in administration capability right within each component, so you know what to expect of it and you can administer the component directly through these interfaces. The types of things that image server can process, for example, are wide in variety and broad in application. The image server is capable of extracting text from scanned images for the purpose of OCR, or optical character recognition. That means that you can take scanned images of forms or other documents that are in your enterprise, run them through the image server, and come out with indexable text, which you can apply to the idle server engine and take advantage of those 500 plus functions that we spoke about earlier in the presentation. We also can identify one-dimensional and two-dimensional barcode readings, other patterns that are images that map to other functions or information, and we can connect them directly using the identification of those images. Unlike other technologies, we can go beyond just the strict matching of the information. We also can use entity extraction to pull discrete little bits of information out of a larger corpus within the same file. And that can be done through eduction or data transformation that's built into the connector framework services workflow. The image server also has capability to leverage some of the underpinnings of the fundamental technology that our technology was evolved from. Original applications were for facial feature mapping and fingerprint matching for enforcement purposes, and evolved to recognize patterns of information in spoken language. The ability to identify a particular image comes with your ability to provide a representation of that image as training so that IDLE can understand what it's looking for first. And then as data is processed through it, it can match that training against all of the data that is processed through that workflow and automatically establish those matches and then take some action based on that. As well, for marketing purposes, and we'll talk about a use case a little bit later, this same type of image matchup can be done not only in the image in its entirety, but also subcomponents of an image, like the identification of a logo illustrated by the Coca-Cola can that occurs in this placement ad. We also can perform functions of analysis which are aligned with human characteristics. So what does that mean? Well, it means that we can not only identify specific individuals, like in this case, recognize the face of President Barack Obama, but we can also identify that there are multiples of gender in this particular photo, the ethnicity of the people that are in the photo, and what color clothing they happen to be wearing at the moment, or whether they're wearing any clothing at all. Those are all very powerful capabilities that are functions exposed within the image server and can be applied to different types of data, whether that's video or still images. So our speech server technology leverages these algorithms that I've spoken about previously. The underpinnings of IDLE server are based in Bayesian algorithms as well as Shannon information theory to identify significant patterns of information and then be able to prioritize them in importance. These dual capabilities are exposed in the speech server as well to be able to identify spoken language, indeed multiple languages, over 150 different languages that we're optimized for, and use the statistical algorithms to recognize the patterns of speech to increase accuracy in the identification of specific words that are used in that language. You can also tune using acoustic modeling so that different contexts of the use of language in the audio track are identified. An example would be a recording of some public event versus a recording of a phone call, where there are differentiations in the types of background noise and things of that nature and volume that are less controllable in a public recording as they would be in a phone call recording. So built into the speech-to-text technology is also the ability to leverage tacit knowledge that IDLE server makes available to us. And what does that mean? It means that we have a learning engine available. That learning engine looks at examples of things that it's processed previously and registers significant patterns within the index that it is maintaining. That is then exposed to enhance the identification of specific entities within the spoken language that exists in the audio track. So in this case, we understand a little bit better about how to predict what words are likely to be used next, and therefore increase the probability that we're identifying the word more accurately. What does this mean to a large corpus of text? It means that we have the ability to handle multiple use cases going from broadcast news to specific recordings of phone conversations and identify colloquialisms, localization of language, slang terms, and so forth, profanity. All of those things can be identified much more accurately using the technology, and we make it adaptable. So if there are particular cases, for example, technical recordings such as this one that use acronyms, quite a bit, as opposed to generalized language or common language, tuning can be performed to adapt the speech server to that use case. So now let's talk a little bit about how we actually apply this technology in your infrastructure. As a reminder, the speech server and image server are components in the connector framework services. And as such, they are accessible through a combination of scripting and configuration. So how do you actually configure the image server to work with IDLE? It comes from the configuration of the connector framework services. And on the right, you can see that there's a little snippet of a configuration file. And in there, you might recognize that we're referencing a Lua script, which calls out the specific functions that are to be performed and other instructions for customized handling of the data that's extracted. We also will address the actual occurrence of an image server in this. In the connector framework services, you're not limited to just one instance of an image server. You can actually set up multiples of them. Each one can either have a dedicated task to it, or you can have multiple tasks invoked in a single call to an image server through the configuration parameters in the connector framework services configuration file. This is important because we can identify the types of information that we want to process. We do want to anticipate what the formats, might be. We are able to accept a variety of formats that are outlined here on the slide, and we also can perform not only the analysis but enrichment of data in that layer to augment the metadata capabilities or the metadata that is available once the data is processed. Speech server has a very similar methodology for being invoked through the connector framework services. Again, you can see an example of the configuration file on the right-hand side of the slide that talks about the import tasks and references a specific Lua script, and also specifies that there's a section that's going to be invoked to perform actions against the audio data or video data that is processed through the speech server. As you might observe on the last line of the configuration, we've got multiple instances of the pattern of server ID and port number, which allow us to distribute the work across those paired identifiers of the speech server. So as an ACI component, it's going to run on some server in your network. It's got to grab a port number to work against, and that's how the application and other components within the IDLE infrastructure communicate with other ACI server components like the speech server. So once we've actually acquired this information and we've begun processing the data through the image server and speech server components, what are the use cases? What do we actually get out of this, which presents the value of the use of the technology? Well, let's take the case of Erasmo, which is a very, very cool technology. If you can point a device to capture an image, that image is then used, once it's captured, to try to match against a similar image or identical image in a database, which then, if upon a successful match, can cause the rendering of useful information or augmentation of the image in form of animation, where other images in motion can be applied over the image that's captured. An example of an application of this is to point at a structure like the museum that's being illustrated in this particular image here, and then present to the end user what the hours of operation are, what the cost of admission might be, what programs are available within that museum for them to register for, classes and so forth. That type of enriched data can be presented once the image has been matched in the IDLE server database. Another example would be, from a marketing point of view, to be able to scan the imprints that have been scanned from magazines or other publications, or online images that appear in websites and broadcasts, and match up the color and type of clothing and products that are featured, like sunglasses or particular wristwatches, for marketing purposes, to be able to correlate the occurrence of those and the availability of those within the data that's been supplied. This has great potential for doing analytics of how impactful a marketing campaign has been. This also can help correlate what products tend to resonate with certain types of broadcasts or certain types of marketing campaigns that have been undertaken by your organization. As well, internally, there's a multitude of multimedia content that many organizations have in the form of stored audio and stored video, which can provide additional enrichment to the corpus of data that becomes searchable and analyzed as part of either an enterprise search or big data analytics project. With the speech server, there are also a multitude of use cases. In this particular slide, we're exemplifying a couple of prominent ones. The e-discovery case is very, very high profile and very popular these days with information governance, because organizations are trying to perform risk mitigation for litigation against their firm, or preparing information to respond to litigation that's already been undertaken. And in those cases, we provide a unique capability to correlate spoken information that's captured in telephone recordings, or other audio sources from within the enterprise, and correlate those to emails and other documents that have been produced, which have also been indexed into the IDLE server engine. Our ability to do this multi-channel analytics is, very, very important to be able to discover the right information and do accurate risk mitigation in a governance context. The call center applications are numerous. Our speech server can process data in real time and analyze the data for voice modulation in identifying that a customer has become agitated, the identification of profanity in the conversation from the customer, heightening the identification of their frustration, and in many cases that can precipitate an invocation of a procedural or workflow process to engage a manager or supervisor into the call to mitigate the dissatisfaction of the client and escalate automatically, the involvement of supervisory and managerial staff. As well, analytics can be performed on call recordings such that we're able to identify patterns of solutions that have been identified for particular clients and map that to their degree of satisfaction. We also can analyze the audio in real time, and having done a speech-to-text operation, we can take that rendering and use it to match documentation, which can help the call center operator to get information for the customer more quickly and have it delivered to them automatically. So we've gone through a number of levels of discussion about speech server and image server. Hopefully you've taken away from this that these components are an integral part of our IDLE infrastructure, not just an add-on or a separate product that you can purchase and start to use separate and apart from the IDLE infrastructure. It's actually built into the IDLE infrastructure. It's commonly accessible as an Autonomy Content Infrastructure server, and the manner in which you address them is consistent with all the other ACI servers that are part of that framework. We have enhanced capabilities within both of these components, both image server and speech server, that leverage our strengths with not only identifying but remembering patterns of usage and matching that more effectively for the use in your applications. The configuration of these components is consistent with all the other configuration strategies for all of the other IDLE server components in the ACI framework. And you can extend and customize them given the facilities that are built into these component products to provide much more customized and targeted solutions that resonate with your environment. Hopefully you found this very useful today. If you have any further questions about how to leverage this technology or means by which you can get assistance leveraging these technologies, please feel free to reach out to me at my email address. That's jose.colon@hp.com. Thank you for your attention.
Thank you very much, Jose. That was a great presentation. So, audience,